This is standard 8GB8, where we're going to apply the Pythagorean theorem to find the distance between 2 points in a coordinate system. So let's see what we've actually got here. We've got a line. It's got 2 points on it, 2 endpoints. Get our pen here. This point is at -2, 4. This point is at 3, -2. How can I find the distance between these 2 points, or the length of this line segment? Well, remember how we used Pythagorean theorem? What if we draw a right triangle? Just like we would if we were doing a translation, just like we would if we were using Pythagorean theorem. Let's draw a right triangle here. Let's go down this line segment. See how far we need to go. Right there. And then let's go over. And we have drawn a right triangle. Now, we can use Pythagorean theorem, and you're wondering, well, how can we use Pythagorean theorem? I don't see any side lengths, but we're going to be able to use Pythagorean theorem to find this side, because this is a right triangle, and I can find these lengths by counting the squares. I couldn't find the lengths here by counting the squares because they're not right on the grid lines, but I can these because they're right on grid lines. Now, first off, let's find our A, B, and our C. We know our C is always across from the right angle. It's the hypotenuse. It's the longest side in a right triangle. That's what we're trying to find, is the C. Let's call this side A, and let's count the side length from here to down there. And these are all in units of 1, so we can just count them straight units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So this side is 12 units long. I'm going to substitute 12 in place of A. Let's try this side here that we're going to call B. Let's see how long it is. How many units long? 1, 2, 3, 4, 5, 6, 7, 8, 9. This side is 9 units long. So we're going to substitute 9 in place of our B. 12 squared plus 9 squared is equal to C squared. See, this is what we're looking for as our C. A right triangle. This is our side that's across from the right triangle. 12 squared is 144, so we're going to substitute 144 in place of 12 squared. 9 squared is 81, so we're going to substitute 81 in place of 9 squared. And C squared, we don't have anything to substitute for. That's what we're looking for, is C. Now, grab your calculator and add 144 plus 81. If you add 144 plus 81, you get 225. So let's substitute 225 in place of this 144 plus 81, and that's equal to C squared. But I'm not looking for C squared, I'm looking for C. I would take the square root of C squared, and what I do on one side of the equal sign, I have to do on the other. So let's see what the length of C is. In your calculator, if you have a TI-30X 2S, you would put in second function 225, second function square root 225 equals, and you would get 15. So in place of the square root of 225, I would put 15. I've substituted 15 for the square root of 225. This tells me that this side length here is 15. Now we know in a right triangle that the hypotenuse is the longest side. This side length was 9, this side length was 12. The hypotenuse, it says, is 15. That would make sense to have 15 as the longest side. The hypotenuse is the longest side. 15 is the length of this line segment, which is the hypotenuse in this right triangle. It is also the distance between these 2 points, -2, 4, and 3, -2. So what we have actually done is use Pythagorean theorem to find the distance between the 2 points when they're on a coordinate grid system.